Ever pondered the mystery of how the tiny, intricate world of electronics comes to life? Or what strange and precious materials form the backbone of these marvels of modern technology? The answer lies in a process that is as complex and fascinating as the devices it creates: the manufacturing of printed circuit boards, or PCBs. At the heart of every electronic device, from the simplest LED light to the most advanced supercomputer, lies a PCB. These tiny boards are the hub, the central nervous system of any electronic device, and their creation is a process of precision and finesse. The process begins with a bare board, often made of a material called FR4, a type of fiberglass. For more high-performance applications, a board might be made of polyamide or PTFE. Regardless of the material, the board forms the physical base for the PCB. Next, the board gets layered with a thin sheet of copper. This copper forms the pathways that electricity will follow through the board. But how do we get from a blank sheet of copper to the intricate patterns that form the circuits? This is where the magic of photolithography steps in. In photolithography, a design of the circuit is printed onto a film. This film is then laid over the copper sheet, and the whole thing is exposed to ultraviolet light. The light hardens the areas of the film that are exposed, while the areas hidden under the design remain soft. These soft areas are then washed away, leaving behind a perfect imprint of the circuit design on the copper. Then, it's time for etching. During etching, the board is bathed in a chemical solution that eats away the unprotected copper, leaving behind only the hardened areas that form the circuit pathways. Once the etching is complete, the remaining hardened film is stripped away, revealing the copper circuits. Now the PCB is almost ready, but there's one more step to go. The board is coated with a layer of solder mask, a material that helps to prevent accidental contact between the circuits and any conductive material. This mask is usually green, which is why most PCBs have that distinctive color. Finally, the board is silk screened with white lettering to label the various parts and pathways. This completes the basic manufacturing process of a PCB. However, a PCB is more than just fiberglass and copper. It's a conduit for electricity, and to do that job, it needs components. These components, such as capacitors, resistors, and microchips, are made of a variety of materials, including precious metals like gold, silver, and palladium. These precious metals are excellent conductors of electricity, making them vital to the function of the PCB. But there's a darker side to these materials. Many of them, particularly the precious metals, are mined in conditions that are harmful to both the environment and to the workers involved. Some components also contain toxic materials like lead and mercury, which can cause harm if not properly disposed of. In summary, the creation of a PCB is a complex process that involves a variety of materials, from the common copper and fiberglass to the precious and sometimes toxic metals used in components. It's a process that is as fascinating as it is important, forming the backbone of the electronic devices that power our modern world. Despite the challenges and environmental concerns, the manufacturing of PCBs continues to be a critical part of our technological advancement.